Please join me in welcoming Bill and Mark up to the stage.
Great.
Okay. Is it true, though, that you really are the most amazing, wonderful? Okay.
I slipped at 20 later.
These are squishy.
They are.
So I actually prepared some hard questions, and we only told them about them a few minutes beforehand, so we'll see how this works out. But all kidding aside, it's been an interesting 2 days here so far. And one of the topics for a number of the talks, a lot of people here have been talking more about what I'll call the OpenStack experience, and not necessarily what we'll call, let's say, the software product, which is OpenStack. So what's your view about this kind of transition to the OpenStack experience, both being a long-term OpenStacker yourself and also kind of as the leader of cloud at HP? Where's this OpenStack experience going, and what's it about?
I always like to think of things as kind of a whole product experience. And so OpenStack provides a set of core engines that people are, and all of our companies are using to build out private cloud infrastructure, public cloud infrastructure, or more specialized vertical clouds. Really, what we're trying to do is get this really focused around making sure that when we've got these engines and we're focusing on the whole product for the application developer. The application developer is the person who we're trying to enable to have an agile infrastructure that allows them to build, deploy, test, and integrate and build a system very effectively. And right now, I think that as we evolve this, more emphasis around libraries, SDKs, CLIs, all the parts of from the day they find, I call it Monday morning. Monday morning, you show up and your infrastructure team goes, we have a new infrastructure, all kinds of new APIs for you to use, a whole bunch of new stuff. Mm-hmm. Like you sit down and you start to read the documentation, you start to type in some example code. What is that like? And I think that increasing our investment in the experience side, whether that's people who understand developer and developer relations, user experience people, customer experience folks, I think they all have a part to play here.
I'm really glad when you were stressing about developers, you didn't do this sort of bomber jumping around the stage developer video.
I can't throw these chairs. I thought about it, but they're too heavy.
Yeah, liability issue. So the next question, and some of the audience knows me, I've been around this for a while, and I'm not really certain how to phrase it, but whether we call it the container problem, the container conundrum, lots and lots of buzz around containers. And part of it is containers really sort of buzzword hot right now, but it's also kind of the main tech trend issue right now. And it does relate to our space of OpenStack. So where do you think, or how do you perceive OpenStack needs to evolve around this container buzz and activity and trend? And maybe you can play that out a little bit.
Okay, great. And certainly, I think the movement towards containers and lightweight systems for deployment is really focused around, again, it's coming back to developers and how do developers have a good, effective life, and getting a smaller footprint for deployment characteristics. I'm excited about the Magnum project that a bunch of folks are leading. I'm not sure if Adrian is still in the room. If you're back there, say hi, Adrian. I think that when you think about providing a layer for Nova to then interoperate with and be able to orchestrate other things aside from VMs. When we first started it was KVM and Zen. All the other hypervisors have shown up now, and we've got good support for across those. I see Nova extending through Magnum in a way to get containers in an effective manner. I think for at least the near term, we're going to see a lot of containers getting deployed inside VMs. We need stronger isolation characteristics, which would get that way. In fact, the earlier versions of Trove, Trove is always deployed that way. It's VMs with LXC. And we did that a few years ago because we realized we wanted to do fast deploys of an image-based MySQL, but we wanted to make sure we had the isolation and security characteristics that we needed with a boundary with a stabilized VM.
Mm-hmm. Interesting. So that kind of leads well to my next question, because you were talking about a little bit about the history and more kind of about the future. And in Vancouver at the OpenStack Summit back in May, you had a keynote right after Jonathan, who I saw earlier walking around. And I think that was actually 5 years after you did, I think it was the opening keynote at one of the first, if not the first, OpenStack Design Summit. And in Vancouver, you reviewed a lot of what 5 years earlier had been your predictions, right? And I don't necessarily want to go back and review all of those, but you were quite accurate in seeing the future, and maybe I should use you to help me rebalance my stock portfolio. But looking forward, what are your predictions or visions of the future based on, you've been around this for a while, and where do you think we're going with OpenStack?
Well, when I thought about the problems we were trying to solve at Rackspace back in the day, I personally had a lot less experience with complex data centers, a lot less experience with where we're going and with systems management and with complex fleet management. And when I look at where we need to go, when I look at kind of OpenStack in general, it seems like there's so many parts that need to evolve at the edges. Mm-hmm. Understanding how we relate to CMDBs, understanding how we relate to other parts of system management, monitoring. When I talk to customers today, they have large data centers that already exist. They're interested in putting in an OpenStack system, but it has to work. It has to interoperate with a set of other existing systems that they're not going to change, at least in the near term. Mm-hmm. And the near term for some of the data center guys is, at least the current generation of their data center, which is 3 to 5 years. So I think we're entering a phase right now in OpenStack where we need to spend more time focusing around making sure that we are good citizens of somebody else's data center. And we interoperate, interconnect, certainly systems like, Neutron, where Neutron interoperates now more effectively with other SDNs and other networking topologies. I think that's been a good success, and that needs to continue. And the last part about it is making the systems more introspectable so that data center operators can connect into them. They need to be not opaque. And I think right now, OpenStack's complexity makes it more opaque than they oftentimes feel comfortable with managing.
That's kind of interesting in that the manageability thing has been kind of a challenge for OpenStack. And it reminds me of something you said at the Vancouver Summit, also in your keynote. You made a joke about initially people needed a PhD in OpenStack, which I thought was partially funny because a number of the original developers for OpenStack all had PhDs in astrophysics and computer science and others. But last week, Tom Fafeld, how many people were at the Operator Mid-Cycle Summit last week? 1, 2, 3, 4, 5, 2 in the far back. So Tom Fafeld from the OpenStack Foundation and Ulf Baumann, who also works at HP, sort of hosted the OpenStack Operators Mid-Cycle. And manageability there was a really significant kind of topic of discussion. And there were a lot of subgroups that were talking about manageability and part of the interoperability in a data center space. Do you see much of a shift in the project and in the community around this between both kind of, dare I say it, your kind of call to action in Vancouver combined with some of the other operator activities that occurred both in Vancouver and the mid-cycle? Yep. Are you seeing much of a change or a shift both in the community and in the industry for this?
I think the community around the operator side is growing rapidly. We had like 150 people attended the 6 month ago Operator Summit in Philadelphia. It was a great East Coast event. We had a lot of people that were running it at scale. They were running it in proofs of concepts. They were trying to figure out how to operate this. We had 250 people. We all got together at the one here in Palo Alto. And really these were all people who were all operating this thing and all working on different aspects of it. And it was an amazing experience because we're all trying to basically understand, oh yeah, I have that problem too. Oh no, you have this problem. And you're trying to find collections of people to talk to about how they're dealing with, doing operations for a long time, there's always something going wrong, right? That's just kind of the nature of any large, complex distributed system. And like the discussion earlier around lunchtime, this is one of the most complex systems that people deploy into the data center. We've got now in the operations area, there's a logging group about how do you get consistent and coherent logging across all the different OpenStack projects, so we can able to bring that forward and bring that into systems and manipulate them. How do you get, and there's a monitoring working group talking about how do we get kind of more effective monitoring of subsystems and areas inside OpenStack. I think one of the things that we really liked about the summit was bringing forth, like let's go find the top 50 bugs of that cause operators grief. And people said, well, you know, we did this 6 months ago and everybody was upset about Rabbit and RabbitMQ and Rabbit stability. So who thinks it's hair on fire? And I'm like, you know, there wasn't a lot of hands. And it's like, who thinks it's kind of like a smoldering embers? And I'm like, yeah, it's kind of like that. And everybody was really happy because we'd taken it from something that was keeping people up on a regular basis to something that seems under control and trending in the right direction. A big shift in this, for example, if you look back just a couple of years, people who were using different networking technologies, and if you were to talk to folks, well, at the summit, they said, raise your hand if you're using Nova Networks. The first thing we did, one hand went up. Okay, who's using Neutron? 240 hands went up. Who wishes Neutron would get a little bit better? Hands stayed up, but everybody's using it, and now they need to make it better and help it mature. And that's kind of some of the conversations about what does maturation really mean. Part of it for an operator means I can inspect it, I can understand its inner workings, I know what to do. And if it's starting to go wonky, it will tell me that actually this is something you need to pay attention to, and if it's just a little bit not quite right, it'll self-stabilize. And so some Nova does this very well. Neutron can continue to try to do that and make it more inspectable so our operators are more confident. Because basically the one thing as an operator, you're never confident the thing is actually happy and healthy. You think it is, but you need to go actually make sure that it's measured and logged to actually provide the underlying picture.
So you just touched a little bit on maturity, and maturity has a lot of different kind of definitions or vectors. We're surrounded by a lot of physicists too. Maybe you can expand a little bit more on, you briefly touched on Neutron, but one of the areas I think for a lot of the enterprise customers that are here and sometimes come to other summits is how mature is OpenStack and where is it maturing? It's ready for the enterprise. There are lots of enterprises that use it, but as it's maturing, maybe you can touch on these sort of different areas or interpretations of maturity and where it is. Maybe you can use some examples, like you started with Neutron or Nova.
Well, so Neutron, for example, I mean, I think the maturation over the last 12 to 18 months with the refactoring of the ML plugins, which has allowed us to have firewall as a service, load balancer, the Octavia project, it's taken a lot of complexity out of an embedded project. Those projects can now evolve at a good rate. They have a nice interface. So those projects, I think, seem very happy. They're more productive. That's allowed Neutron to focus more on what its core is, and I think it's a very good aspect of maturation. We saw that earlier with Cinder and other systems getting pulled out of what used to be purely Nova, because Cinder kind of came out of our the storage subsystem. When I talk to enterprise customers who've got multi-data center situations, they've got complex workloads that have certain characteristics. One of the things people say is, I want to go understand how the scheduler works, because I really need to have complex affinity or anti-affinity rules. I need to be able to express a complex topology, and I want Nova to take care of that for me. What do you got? I'm like, yeah, I don't have as much as I wish I had. Let's talk more. I want to understand what your needs are. But I wish that was an area where we could continue to grow and make it more mature and bring it to the next level and really catalyze more of some of the scheduling things that you see in some of the other projects that are happening. I think those are some of the main things.
Okay. Yeah, I mean, I think somebody made a comment earlier about, they thought about Nova in terms of, for compute and in the data plane, highly mature.
Yes.
Very rich. Others, but from an operator perspective, they want to use, they want to do, as you said, special things with the scheduler, and it's maybe weak there. So it's that kind of vector aspect. How do I tweak the scheduler to do this?
Yes, and I think look, I think the Nova team is doing really good work, and I think that if you come back and you were to kind of ask the question of, if I want to give you a resource, how long should it take for me to figure out what resource to give you? If you kind of assume a distributed system in a distributed manner, it ought to take about a millisecond or 10. I always think about this the way I used to work at Yahoo, and we did everything. We did almost all of our computed RAM. We had many things as pre-computed as possible. We knew what statistically the next set of queries were going to be. So Nova kind of has the opportunity to know many things, and why not make sure that we bring it, as we want this thing to scale to 10,000, 100,000, a million machines, you've got to make sure that the time spent and the complexity spent in doing the next action is at the very lowest levels.
Okay, wow. So in the interest of time, because we got about 4 minutes left, I'd like to take it back to sort of the vision prediction aspect, and maybe bind it a little bit in time, not only in the time we have left remaining up here, but let's look at, like, between now and 2018, since you mentioned the sort of recycle of the capital estates inside enterprises and others, and in many ways more of this audience is enterprise-based than core contributors into OpenStack. What really is the vision that you see driving as a leader in the community, and maybe a little bit where you're driving HP, where you and I work, towards to fulfill what you see as that vision?
Cool. I think the biggest thing I'm talking about internal to my teams is manageability and making this thing operate effectively at scale with 1/10 the number of operator resources that it has today. And some people go, where'd you get 1/10 from? I said, I got 10 fingers as 1/10. And because some people worked with me before, they said, well, how are we going to do CI/CD? I said, it's easy. We're going to cut the time it takes to do our CI in half, and we'll keep doing it and keep doing it. So we're going to we want to drop the operator complexity by 10. We'll look at it again, and we'll figure out what to do next. But drop it 2 10s, and I think we're in amazing shape. I mean, for a lot of people who are running it today, we're in great shape. But if I could take your operator costs down by a factor of 100, everybody would go, I could buy more machines, I could go hire more developers. Things would get a lot more dramatically better. When I think about how software is supposed to work as a child, when I kind of watched Star Trek as a kid, and I was always wondering, like Star Trek, they always were concerned that the ship is going to fly into the sun or the Earth or a planet. And I'm like, the first rule of software, which is a big complex system, is don't fly into the sun. So how do you get more of the thing to be more quasi-stable so that it just, skims by Mercury's orbit and you're kind of cool, a little bit warm? So I absolutely think over the next few years, we need to find all of the common cases and continue to drive down the areas where it gets a bit wonky. So one of the things we're doing inside HP, we're talking to all the people that are operators within our team. And we're going like, what did you do yesterday? Walk us through, where did you spend your time? What were you looking at? I want to understand and have our designers and our software product people understand what it takes to run this and find out ways that we can help either make blueprints in the community, fix a bug, change something, so that we're basically making it easier and easier to know where the system is and help it get quasi-stable. The talk earlier today, I think Mark Shuttleworth was talking about the phase shift in these complex systems, and the tools need to rise to support the complexity. Well, that set of operator tools really needs to come out in the next few years, because the software itself needs to be able to be more adaptable. And part of that is a system that is watching it and effectively monitoring and remediating. Look, some of the really great companies just a couple of miles from here have more sophisticated auto remediation systems that mean you can manage more effectively the capacity and the systems and the stability. I think there's some really good research that's getting published in that area, and I think some of that is where I want to start to have us look for it. Okay,
we have one brief, like 1 minute left, so I'm going to ask you one or two questions you and I didn't chat about, just to prove to people this was not a rehearsed exercise. So one of the things that I know working for you is you not only being a little bit of a futurist and a visionary, but you're also very involved in what's happening in the industry and in the Valley, and you talk to a lot of people and others. So we've got Tokyo coming up in 3 months. There's people going from HP, people from Rackspace, all sorts of people that you know in the community. What are some of the things that you're interested in seeing at Tokyo and hearing about?
So I would be very interested in having more and more blueprints and more design conversations around auto remediation, around reliability, around people offering data on root cause issues. And so I'll commit to that we will provide more data about root cause issues that we're seeing. We'll make those available from our cloud systems. I want to make sure that that the stuff is out there, because if you show people the data, you show people kind of what happened, they'll be able to problem solve ways to get the 5 whys. You'll be able to go back up to the actual root cause, figure out what needs to get changed in one of the future kind of N or O releases, because it'll take us a while to figure some of this out. But I'm looking for more conversation around reliability engineering. If we want to build a system that has 100,000 physical machines of deep complexity, all kinds of different workloads, we've got to start to have more of the reliability conversations. For anybody go to the Velocity conference? It's a fantastic conference. It's running web reliability at scale. There's one here and there's one in London. It's a bunch of people from the big tech co's. I've been many years. It's a great way to learn about how everybody, the set of people, are making their systems more deeply reliable in the presence of all the things that happen in the world. And I'm looking forward to seeing folks in Tokyo.
Yeah. Well, I look forward to some of the areas you've talked about in Tokyo. And I really want to thank Lisa Marie-Namphy, who works for HP, and Robert Cathy, who asked Mark and I to sit up and chat with you for a while. I love the opportunity to get to interview my boss on stage, and we've done it a few times before. So thank you very much.
Well,
Mark,
thanks a lot. Hey, great job.
till next time.
Till next time, yeah.